Direct variation is when two variables are related by a constant ratio. There's a relationship between these two numbers that does not change. So here's an example. Feet and inches are an example of direct variation. The ratio between them is 12. If I have 1 foot, that's a total of 12 inches. If I have 2 feet, that's a total of 24 inches. And this pattern continues forever. Just one more example of 10 feet would be 120 inches. I know exactly how many inches I have if I know how many feet I have because the ratio between them is 12. So here's another example. For every package of cookies that I eat, I drink 1/3 of a gallon of milk. The ratio between cookies being eaten and amount of milk being consumed is 1/3. So if I have 1 package of cookies, I'm drinking 1/3 of a gallon of milk. So then if I'm eating 2 packages of cookies, I'm drinking 2/3 of a gallon of milk. And if I were to eat 10 packages of cookies, in addition to a tummy ache, I would be drinking 10/3 gallons, or 1/3 of a gallon, which translates into 3 1/3 gallons. But the ratio is always 1/3. So this is going to be our definition of direct variation, or what it looks like in equation form, and the equation is y equals kx. And we know that in algebra, when two things are written right next to each other, like these two letters are, that there is an operation happening in between there, and it is multiplication. I'm going to show that little multiplication, that dot there. You can write it in your notes. I'm going to erase it though because you guys know we don't show that in algebra. We just know that two things written right next to each other, it is assumed that we're going to multiply them together. So in this definition, we have two variables, x and y, x and y. And I know it looks like we have 3 variables because of this letter k right here, but this letter k is actually going to be some constant number, so a number that doesn't change. And in our 2 examples that we just talked about, here's how we would write the direct variation equation. So these are examples of direct variation equations. So for the relationship between inches and feet, the equation is y equals 12x. So if I was wondering how many inches there would be in 5 feet, it would look like this. Inches equals 12 times 5. And 5 times 12 is 60. So there would be 60 inches in 5 feet. And I could do that same thing with this equation that I wrote down here about the milk and cookies. If I wanted to know how much milk I would be drinking, it depends on how many cookies that I'm eating. And I could do the same thing there. If I wanted to know how much milk I would drink if I ate 5 packages of cookies, I'd plug in 5 there. And I'd find that my answer would be 5/3 of a gallon. We wouldn't really ever say 5/3 of a gallon. It's an improper fraction, which is totally fine, except when we're talking about real life things. It's usually better to turn this into a mixed number. 3 goes into 5 once, with 2 left over. So in other words, I'd be drinking 1 2/3 gallons of milk. So this letter K, this constant number, it's really important, and it does have its own vocabulary word. It has its own special name. It's called the constant of variation. And that's the constant ratio between two variables. Excuse me, that should have an S. Two variables that show direct variation. Please remember, best part about these videos, you can pause whenever you need to and continue watching once you have everything written down. So I've got 2 graphs here ready for us to graph those 2 equations, y equals 12x was our equation for feet versus inches, and y equals 1/3 x was our equation for milk versus cookies. So if I have 1 foot, that's 12 inches. So I'm going to count on this side by something greater than 1. Otherwise, I'm not going to be able to put very many points on here. I'm going to go ahead and count by 5s. So this will be 5, 10, 15, 20, 25, 30, and so on. I'm not going to label all of them, but we're just going to see what will this graph look like when we graph it. So when I have 1 foot, I have 12 inches. So that's the point 1 comma 12. So 1 comma 12, here's 10. It's going to be a little bit higher than that. And when I have 2 feet, I have 24 inches. So 2 up to 24, it's going to be about right there. And if I have 3 feet, I would have 36 inches. So 35, 36. You should be able to tell that this is going to make a straight line. So if we have a direct variation graph or an equation, we should be able to represent it with a straight line. And what that will allow us to do is predict further out. If I came out here to maybe 11, I would be able to come up and find on that point how many feet we were talking about. The same thing's going to happen over here with the milk and cookies. If I have 1 package of cookies, I'm going to be drinking 1/3 of a gallon of milk. So I'll count these as thirds. This will be 1/3, 2/3, and 3/3, which is 1 whole. 2/3, there's 2 gallons, and 3 gallons. So if I have 1 package of cookies, I'm having 1/3 of a gallon of milk. If I have 2 packages of cookies, I will have 2/3 of a gallon of milk. And let's jump out a little bit. Let's go to 5, which we found on the last page, was 5/3, which is 1 and 2/3. It's going to be up here. And we should see on this as well that we're making a straight line. Is pretty good for not being able to use a ruler on this program. So here's a different example that we haven't seen yet. You pay $36 for 3 used video games, and I'm asking you to write a direct variation equation. Well, we know what direct variation equations look like. We've seen 2 examples now. And this one you might be able to figure out pretty easily in your head if you know the relationship between 36 and 3. But if this were a more difficult problem that did not use 36 and 3, I want to show you how we would figure this out. So I know that a direct variation equation looks like this, y equals kx. So the first thing I need to do is find k. I'm trying to figure out what is that constant number. So what I'm going to do is I'm going to fill in 36 and 3. So if I buy 3 games, that's my x, it's going to cost me $36. So 36 equals, well, this kind of looks weird. Let's rewrite that how we would write that in an algebra class. 3k. Okay, now I can see if I divide both sides by 3, I can see that my k is 12. So when I go to write the direct variation equation like we just did on the page before, the number that belongs here is 12. That must mean each video game costs $12. I'd like you to sketch a graph of this on your own tonight, prove that it makes a straight line. And then using your equation, okay, so not just write the answer, but using your equation, I want you to show how much 7 games would cost. And then your final task for this evening, write your own direct variation question using the previous question as a model. So come up with a scenario similar to this, where you're going to ask the person next to you tomorrow, you'll trade papers, and ask them to solve your direct variation equation.